Mr. Davies' Dose of Science. If this is your first time learning with us, welcome. If not, welcome back. Hello everyone, it's Mr. Davies, back with another dose of science. Hope you're all doing well and feeling healthy. For today in science, we're going to be looking at volume, specifically how to find the volume of any object. To do this, we're going to use the web page, Canvas, your packet, and a video to follow it up at the end. So in order to get started, let's go ahead and take a look. We'll start at the web page and go from there. As you can see, this is the Mr. Davies Science web page. A number of things are here for you. Okay, so we're going to go ahead and sign into Canvas here. As we do, don't forget you're going to have to select your block. I'm going to use block A just for demonstration purposes here. So the packet that we're using is located right here. Understand that there are additional activities, but you're only being graded on the assignments. So do take a look at the packet. That's where I do get the information for these instructional videos. Also, as you come back around, the video at the end will be the Richard Louis video. He does a really good job with displacement. So if you're following along in the packet, you're going to want to use this link. Go ahead and pull that up now. Vocabulary is always important. So as we encounter these words such as mass and weight from yesterday, certainly take some time with those words to make sure you understand them. And today we'll talk about volume. Tomorrow we'll finalize it all out with density. The two pages I'll be using today primarily are numbered 19 and 20. They're about halfway through your packet, page 8 in your packet. Right, so basically there are two ways to identify the volume of an object. This section explains that volume is a measure of the space that an object takes up. We are going to read to find out how to calculate the volume of a cube and then follow that up with a cylinder. When you're finished with this section, you should be able to explain what three things you need to know to find out the volume of a rectangular box, as well as the approximate value of pi. Volume is how much space an object takes up. Scientists use the metric system to measure volume. Solids are usually measured in cubic centimeters. Liquids are usually measured in milliliters or liters. Here's an important fact. 1 milliliter is equal to 1 cubic centimeter, also called cc's. In the United States customary system, we use a different standard of measure. We use cups and gallons. The volume of an object can be found in several ways. For shapes like cubes and boxes, volume is easy to find. Use this formula. The width multiplied by the depth multiplied by the height is equal to the volume. So here you have your example. It looks a lot like a cube or a brick, and they've measured it three different ways. Maybe if I demonstrate, it'll be easier. So regretfully, I don't have a centimeter ruler today, but I do have a brick. So what they're talking about here is you would need to measure three ways. For example, if you would measure this direction, you might consider that the length. and then you might measure this direction to get the width. That would give you the area of this face of the brick. But then you also need to multiply that by the depth or the thickness. When you multiply those three measurements, 1, 2, and 3, then you can find how much space this brick takes up. That would represent its volume. So that's what they're asking you to do right here. Go ahead and use these three measurements and calculate the volume of this rectangular solid using this space or a separate piece of paper. If you came up with 480 cc's or cubic centimeters, then you're correct. Good job. Now I should let you know that there are formulas for calculating the volume of all sorts of geometric solids. The next one we're going to look at is a cylinder. So here's another way to think about it. You find the area of the base, the shape's base, and then multiply that area by its height. When we consider the shape on the right, this is a cylinder. Its base is a circle. The area for a circle is pi multiplied by the radius squared. That symbol is the Greek letter for pi. Pi is equal to 3 1400 approximately. The r is the radius of the circle. That goes from the center of the circle to the outside edge. You can find the volume of cylinders by using this formula. The height multiplied by pi multiplied by the radius squared. So that's what they're demonstrating here. Try to make it a little easier for you to visualize. I have these old discs. They're DVD recordable discs. So, okay, you would need to have basically two different measurements. You would need to have the radius, which would be the measurement from the center of the circle to the outside edge. You would multiply that by pi after squaring it, okay? So if this is like 4 centimeters, you would do 4 times 4 to square it, and then multiply that by pi, and then don't forget to multiply it by its height. So the radius squared times pi for this surface area, and then multiply it by its height to get the volume. Archimedes was a mathematician who lived in ancient Greece, more than 2,000 years ago. He discovered pi. Archimedes found that the ratio of the circumference of a circle to its diameter was always the same number. Do a web quest to learn more about Archimedes and how he made his calculations. Now, what happens if it's an unusual object? Something you really can't measure, or something where there's no formula for it, like a rock. Well, you need to be able to find the volume in a different way. Some objects, like rocks or toy cars, are not uniform in shape. How do we find the volume? Well, you measure how much they cause water to rise. This is called displacement, guys. You fill a graduated cylinder or some other measured container for water with a known amount of water. You record the level of the water. You then place the object in the water. and record how much the water level increases. The difference between the two measurements is the volume of the object you put in the water. So I do have a couple of small demonstrations here. I'll admit they're not the best. But okay, here goes. Okay, so went ahead and got about, what is it? Sorry, wrong side. 700 milliliters of water, okay? And if we take our unusual object here, starting with the rock, place that in the water, you can see the water level only came up just a little bit, okay? So this might not be the best demonstration, but perhaps the rock would be 10 milliliters, 10 cubic centimeters. If we try something else, without losing any water, hopefully. I borrowed Seamus's favorite red ball. He's very jealous. He's sitting right behind me because he really wants it back badly. But okay, so we have 700 milliliters to start with, right there. And this is going to be a pretty dense ball. So as you can see, the water level went from 700 milliliters up to a little bit over 800, so maybe 830 milliliters. So the difference would be that 830 minus the 700, which would be about 130 milliliters or cubic centimeters. Okay? That would be the volume of the ball versus the volume of the rock. All done by displacement. I'll give it back in a second, buddy. I know. You want it badly. Go ahead. Okay. All right. So we did our reading there. Looked at a couple of examples. There are a couple of follow-up questions that you could certainly take a look at. What are two ways that scientists measure volume? One's by calculating the volume, and the other's by displacement. What role does water play in measuring the volume of objects with non-uniform shapes? Displacement. Okay. Very good. Next, I do want you to take a minute or two to go back to Canvas. One of the better videos to demonstrate displacement is Richard Louie. I believe he did the video on his own in his apartment, but the content is very good. So take a few minutes to check out his video if you haven't already. He also does a number of good demonstrations on the math behind it and what it means as far as floating and sinking. And we'll definitely take a look at that more tomorrow when we talk about density. As always, please stay healthy, stay safe. Till next time, this is Mr. Davies and Seamus. Have a great day and keep on learning, guys. If you learned something today, please like this video. If you think there is more you can learn, then click subscribe or consider coming back again tomorrow. The information, likenesses, and opinions in this video are the intellectual property of Mr. Mike Davies. While Mr. Davies does refer to other works owned by others, those resources are either parts of a public school district curriculum or they are readily available through open forums on the internet. Mr. Davies does offer his thanks and appreciation to any entity he has chosen to refer to or gather sound bites or clips from to emphasize his lessons. Mr. Davies is currently a professional member of the teaching staff for Central Dauphin School District in Harrisburg, Pennsylvania, and is making, producing, and publishing these videos for the benefit of his students and other students during the current lockdown crisis. Mr. Davies does not make claim to all of the ideas and resources referenced in his videos. However, he does claim responsibility and rights to his likeness, opinions, and the academic content of these videos. He does not grant permission for any entity to copy or duplicate any portion of this video or any of his videos for private or personal gain.